It starts with raw potential, nickel aluminum bronze, chosen for its extreme resistance to saltwater corrosion.
Inside the induction furnace, electromagnetic fields will soon generate temperatures exceeding 1200 degrees Celsius.
As the solid metal surrenders to the heat, it transforms into a volatile, glowing liquid.
Impurities are skimmed from the surface. Only the purest alloy will form the blades of a megaship.
For 48 hours, the casting rests. Rushing this process would shatter the crystalline structure of the bronze. 20 tons of liquid bronze cascade into the sand mold, taking the negative shape of a massive 5-blade propeller.
Exothermic powder insulates the risers, ensuring the metal cools slowly and prevents internal shrinkage cavities.
Held at 650 degrees, the alloy's grain structure realigns, maximizing its toughness and fatigue resistance.
A violent water quench locks the optimized metallurgical structure in place, preparing the bronze for heavy machining. After the quench, a visual inspection ensures no thermal shock cracks have formed on the critical blade surfaces. Internal ceramic cores are manually extracted, clearing the complex geometry of the propeller hub. Next is heat treatment. The propeller is baked to relieve internal stresses caused by the uneven cooling of the cast. The sacrificial risers, which fed molten metal during casting, must now be removed.
High-amperage plasma torches slice through 10 inches of solid bronze, removing the casting gates. The rough turn peels away the oxidized cast skin, bringing the central hub closer to its final cylindrical dimension.
The central bore is machined to a precise taper, ensuring a perfect, vibration-free fit onto the ship's drive shaft.
Now, the real sculpting begins. The casting enters a massive 5-axis CNC gantry mill. Mounted on a vertical turning lathe, the propeller hub is centered to within a fraction of a millimeter.
Now, the real sculpting begins. The casting enters a massive 5-axis CNC gantry mill.
A touch probe maps the exact physical geometry of the rough casting, aligning the digital toolpath with the physical metal. The roughing pass begins. Large indexable cutters aggressively remove bulk material, revealing the blade's aerodynamic profile.
Hot bronze chips must be constantly cleared to prevent them from being recut, which would damage the expensive tooling.
Semi-finishing tools smooth out the aggressive scallops, bringing the blade within 2 millimeters of its final dimension. The leading edge is critical for hydrodynamic efficiency. The machine tilts to sculpt a perfect, razor-sharp entry point. For the final pass, the machine automatically swaps to a pristine finishing tool, ensuring a mirror-smooth cut. The final dry cut pass leaves a gleaming, near-mirror finish, achieving the exact hydrodynamic pitch required. The final dry cut pass leaves a gleaming, near-mirror finish, achieving the exact hydrodynamic pitch required. Post-machining inspection verifies the blade thickness. Even with 5-axis CNC, human verification is mandatory. In the finishing bay, master craftsmen take over. Hand grinding blends the machine marks into a flawless surface. Flexible shaft grinders erase the microscopic tool paths left by the CNC, creating a perfectly continuous surface.
Custom pitch templates verify the blade's curvature. Even a millimeter of deviation alters the ship's fuel efficiency.
Eye spots are gently kissed with an orbital sander until the template sits flush against the bronze. Fine polishing not only looks beautiful, a mirror-smooth surface reduces hydrodynamic drag, saving thousands of tons of fuel.
The central hub receives the same meticulous polish, ensuring uniform surface tension and aesthetic perfection.
Before final approval, the propeller undergoes non-destructive testing. The surface must be surgically clean.
Ultrasonic waves penetrate the bronze, searching for hidden internal voids or microfractures invisible to the naked eye.
Red dye penetrant is applied to high-stress areas. It will seep into any surface-breaking defects.
The root fillet is meticulously blended. A sharp corner here would create a stress riser, leading to catastrophic blade failure.
A white developer powder draws out the dye. A clean white surface confirms the bronze is free of surface cracks.
Static balancing ensures the propeller won't vibrate at high RPMs, which could destroy the ship's stern bearings.
The propeller is spun on a frictionless mandrel. Gravity reveals the heavy spot, which must be corrected.
Grams of bronze are carefully removed from the heavy side until the propeller achieves perfect static equilibrium.
A random stop confirms perfect balance. The propeller is now ready for its final assembly and coating.
Critical mating surfaces are meticulously masked off. Bare metal is required for a perfect electrical ground and mechanical fit.
A heavy-duty epoxy primer is applied, providing the first line of defense against the corrosive ocean environment.
Unmasking reseals the pristine machined surfaces. The sharp paint line is a hallmark of quality craftsmanship. The lead engineer conducts the final white glove inspection. Only his signature releases the propeller for shipping. The delicate machined bore is shielded with a heavy-duty protective cover to prevent transit damage. High-density foam protects the razor-sharp blade edges from chipping during the long journey to the shipyard. A custom-built, heat-treated timber crate is constructed around the propeller, designed to withstand rough ocean freight. Clear stenciling ensures crane operators at the port know exactly how to handle the 24-ton payload.
The finished propeller leaves the foundry. It's a monumental lift, marking the end of its manufacturing journey. Secured with heavy steel chains, the propeller is locked down for the overland journey to the shipyard. It's a heavy haul. The propeller begins its final transit to the shipyard, where a mega vessel awaits its heart.
Arrival at the shipyard. The colossal hull of the vessel highlights the sheer scale of the engineering involved.
The crate is stripped away, revealing the flawless red finish. It's time to mate the propel.
The ship's drive shaft is meticulously cleaned. Even a speck of dust could compromise the friction fit.
Guided by master riggers, the 24-ton propeller is threaded onto the shaft with millimeter precision.
A hydraulic nut forces the propeller up the taper, creating a massive friction lock that will transmit tens of thousands of horsepower.
The final locking nut is torqued to specification and mechanically pinned, ensuring it will never back off at sea.
A streamlined fairwater cone is bolted to the hub, smoothing the water flow and reducing hydrodynamic drag. Zinc sacrificial anodes are attached. They will willingly corrode, protecting the vital bronze from galvanic decay. The final sign-off. The propeller is fully integrated, and the ship is ready to meet the sea. The dry dock floods. For the first time, the propeller is in its natural element, buoyant and ready.
Deep in the engine room, the main engine awakens. Power is about to be sent to the stern.
Sea trials begin. The ship leaves the harbor, relying entirely on the bronze heart spinning beneath the waves. Full ahead, the engine delivers maximum torque, and the propeller bites into the ocean. Beneath the surface, the hydrodynamic profile performs flawlessly, converting rotational force into massive forward thrust.
A perfect wake confirms the efficiency of the design. The world's largest ships keep moving, thanks to the forge.
Back at the foundry, the bay is empty, but the legacy of their craftsmanship is already crossing the globe. Forged by the sea. Built to conquer it.
The shaft turns. The perfect balance achieved in the factory translates to a vibration-free rotation.
Sensors confirm zero vibration. Trial data is logged for the Classification Society.
Sea trials are a resounding success.
The vessel returns to port for final handover.
The ship is officially handed over to its owners.
Cargo is loaded for its maiden commercial voyage.
The maiden voyage begins, crossing the open ocean.
The propeller pushes through heavy swells effortlessly.
6 months later, a routine inspection reveals the propeller's durability.
High-pressure washing removes minor marine growth.
The bronze shows zero signs of cavitation, erosion, or pitting. Sacrificial anodes are replaced, having done their job perfectly. Minor cosmetic touch-ups restore the anti-fouling coating.
The ship is refloated, ready for years of continuous service. From canal to canal, the propeller drives global trade.